Welcome to this video on AWS Cloud Data Integration. The technology and data landscape continues to change and evolve. Many organizations have adopted AWS cloud-based technologies to store and manage their data assets. On AWS, data can reside in different technologies. For example, Amazon Redshift, Amazon S3 buckets, Athena, Aurora, and more. Data is distributed across different locations, in different formats. It is required for different purposes and used by many different personas across the business. The challenge is making sense of your data landscape and how it can be integrated to provide true business value and quickly. So how can we solve the cloud data integration challenge and deliver data in a more accelerated and agile fashion? We can solve the challenge by using a logical approach and leveraging a technique called data virtualization. Data virtualization can help your organization integrate your AWS cloud-based data very quickly and easily without any need for data replication. A common scenario is where we need to understand the customer in-store sentiment. We will need to source data from 3 different places in this case: sales transactions from Amazon Redshift, customer demographic data from Amazon Aurora, and marketing data about customer sentiment will be sourced from a software as a service application via an API call to get the JSON array document. Denodo allows us to connect and combine these disparate data sources across the AWS cloud environment and present it to data consumers in different types of tools such as AWS QuickSight, Tableau, or even publish it as a web service. So let's now take a look at how this can be done in the Denodo Design Studio. We can address this requirement in 3 simple steps: connect, combine, and consume. The first step is to connect to the data sources. In Denodo, there are hundreds of out-of-the-box connectors, and native connectors are also supported. On the left-hand side, we will see the data sources that we will use to create our single view of a customer. Here, the connection for Aurora, where our customer information is held, is connected via JDBC. There are over 1 million customers in this customer table. Similar to the first connection, we will use the JDBC driver from Amazon Redshift to retrieve the product sales history information. There are approximately 70 million sales transactions in the Enterprise Data Warehouse source in this case. And then finally, we will look at the software as a service application that will give us a JSON source for customer sentiment. This array will be flattened and rendered in a 2-dimensional SQL format so that it can be easily combined with other information. As we connect to each data source, a base view of the data is created. This is a logical representation of the physical underlying data source, a one-to-one mapping. Only the metadata is stored in Denodo, not the data. As you can see, we have already created the base views for the data sources required: customer demographics, customer sentiment, and store sales. Once these base views are created, our next job is to use these base views to create the final logical view called store sales sentiment. Let's go to that view. Note that Denodo is not storing any actual data, and it captures the metadata to build the logical business model. The next step is to model the data based on this requirement. Denodo's simple to use, easy to use graphical user interface allows data engineers to model data quickly via easy navigational and drag and drop actions. Relationships between AWS-based datasets and other sources are defined within the logical model so that consumers need not be concerned where and how the data is brought together. It is handled by the data virtualization layer. If you want to bring in an additional table to your model, you simply drag and drop that into the design canvas and define the join definition. Now that we have modeled the desired output, let's run the query and return the results in real time. Denodo's optimization engine will make sure that the right query is run and in the most performant time, leveraging the power of your existing AWS technology investments where possible. The Denodo engine utilizes many different optimization techniques to ensure there is no unnecessary load on your source systems and minimal data is transferred across the network. Now that we have run the query and retrieved the results, we can look at the execution trace. We can see through the execution plan that optimization has taken place and the query has been pushed down to the different sources, which minimizes the data movement through the network and produces the aggregated results, which then can be consumed by any BI application or an API call. The final step is to consume the data via a BI tool using the logical view already defined. In today's demonstration, we'll use Tableau. You'll see we've got available to us the store sales sentiment. There is no need to redefine the logic by which the data is sourced and combined. This is all managed within the data virtualization layer. I can easily take my customer sentiment, the measures for that, and plot the data in a consumable fashion. In this case, I'm using a heat map to show the customer sentiment at different stores. And we can change the colors to suit. Under Data Analytics and Data Integration, you will find Denodo Professional. Start connecting and stop collecting data using Denodo Professional today. That concludes the video, and thank you for watching.